Okay, so the man is 6 feet, that's constant. The lamppost is 15 feet, that's also constant. He is walking at 5 feet per second. So this green line that they have drawn in here, that is him walking away from the light. So that is changing because he is moving. And there's two questions here. So we're going to do this as a part A and a part B. Part A, how fast is his shadow lengthening? So that's this gray line that they have here. And then the part B, how fast is the tip of his shadow moving? So that's this red point that they have. So we'll have him walk and you can kind of see what's going on. He's moving away from the light. Looks funny because he's a stick man. But his shadow is getting longer and also the tip of his shadow is moving as he walks. And then he starts over just like in real life. I can't make him stop. Oh well, that's okay. All right, so we're gonna draw a picture for this. All right, and so I hope you already noticed that we have like, you know, the mommy triangle and the baby triangle. We're gonna have similar triangles here. This is the man, he is 6 feet. And then this is the lamppost, it is 15 feet. Those are not changing, they are constant. So I can put them in the picture as actual values. Everything else is gonna have to be a variable. So this part that they had labeled with green, that's the man walking away from the lamppost. I'm gonna call that X. And he was walking at a rate of, what was it, 5 feet per second. All right, so dx dt is 5 feet per second. So he is walking at 5 feet per second. That x distance is getting larger. And what we're being asked for is, in part A, I'm going to call this like a part A here. How fast is his shadow lengthening? So this distance, they had it in gray. That would be his shadow. I'm going to call that y. And so we're being asked for dy dt. That's the question mark. And it should be positive because the shadow is getting longer. Now, you can't do Pythagorean theorem for this because you don't have the hypotenuse of the triangle. So we're going to have to do a similar thing to what we did up here with the ratios in the triangle. So let's do the big triangle first. 15 matches up with 6. We're going to have 15 over 6 equals, and then down here, the whole triangle is this whole distance. So that would be x plus y. And that matches up with just the small triangle, which is y. So it's 15 over 6 equals x plus y, the whole distance, over just y, just for the smaller triangle. And so again, we're going to cross multiply. And so we're going to have 15y equals, and when we go this way, we have to distribute the 6. So it'll be 6x plus 6y. And then you can go ahead and take the derivative right away. I would get all the y's together first. So I'm going to subtract that over. We'll have 9y equals 6x. And so this is just about the easiest derivative ever. Derivative of 9y will be 9 dy dt. And derivative of 6x will be 6 dx dt. There's almost nothing to that derivative. And then we're going to plug in. We're looking for dy dt. And we're told that dx dt, that was the rate at which he was walking, is 5. And so good. This would be 30. We're going to divide by 9. So 30/9, which does reduce, but who cares? You can just leave it as 30/9. What would that be? 10/3. You can reduce it if you want. And the units are feet per second. Now, the part B for that was how quickly is the tip of his shadow moving? That's this point out here. So that means we need this entire distance the whole way from the lamppost to the tip of the shadow. So I'm going to call that Z. You might be like, hey, Ms. Cole, we already had something for that. It was X plus Y. The reason that that won't work is we're going to need to do a derivative of that distance, and you can't do dx plus y dt. Like you have to call it its own variable. So I'm going to call that z. All right, so we've named that z, and we're going to set up another ratio. So we're going to have 15/6 equals, and now this time the entire length of the bigger part of the triangle, we're calling that z. So that would be z over just the little triangle would be y. And we're going to cross multiply again. So that would be 15y equals 6z. And then again, it's like just about the easiest derivative because you almost don't even have to do anything. It's 15 dy dt equals 6 dz dt. And we're looking for dz dt. We're looking for how is this length changing, because it's the tip of his shadow all the way out there at the end. So dz dt is what we're looking for. And we found dy dt in the previous part of the problem. That was 39ths. Actually, I will reduce that when I type it in here, or when I write it in here so that I'm using smaller numbers. That would be 10/3. And then you just need to divide over the 6. This would be 15 times 10/3 over 6. And again, the units, yeah, and Morgan wrote it in the chat, like reduced down. That's totally fine. It would be 150 over 18. And then that would actually reduce, gosh, those will both divide by 3. So that'd be what, 50 over 6. Actually, then it'll even reduce further. It doesn't matter. I don't care. It's feet per second. And that is dz dt. So I think I am going to stop there because I only have 6 minutes left and that won't be enough to do the last one. That's totally fine. We'll just do that one and plus a bunch more examples next time.